My name is Amanda Nicholson, and today I'll be presenting optimizing injection molding cycle time using simulation. So let's dive right in. First, we are going to go over the injection molding cycle overview, talk about how to optimize fill, pack, and cool time, and then go over a summary so that you know which results to use in order to optimize each phase of the injection molding cycle. The injection molding cycle is made up of multiple different stages, starting with mold open and ejection, and then mold close so that you can make a new part. These are not things that we can cover in simulation, so they're not going to be discussed during this presentation. However, we're going to focus on the filling, packing, and cooling stages. So of course, we start by filling the mold with the vast majority of the material that's going to make up a part, and then we pack it to compensate for shrinkage and also fill out that remaining 2 to 5% of material. And then we need to cool it so that the part can withstand the forces of ejection. And when it drops into the bin, we certainly don't want it to deform. When we start optimizing, we're going to start with our filling phase. And to do that, we're going to evaluate the balance between shear heating and cooling from the mold. So we know that polymers actually have fountain flow, so they flow in layers rather than flowing like water, which can be turbulent if you flow it quickly enough. So those different layers of polymer flowing at different rates generate friction, just like when you rub your hands together for warmth, and that creates heat. So that's the shear heating that we're talking about, and that is in direct competition with cooling from the mold. Now, obviously, we put cooling systems into our molds because we want to pull heat out of the plastic so we can eject it. But if we have too much cooling during the fill phase, we can struggle with things like increased viscosity from the cooling taking a lot of pressure to fill, and a temperature differential across the part that can make it difficult to pack and cool evenly. So it's very important that we optimize our fill time before moving on to the pack phase. When we're optimizing pack, at the press, what you would actually do is called a gate freeze study. So you would inject material into the mold and then pack out for a certain amount of time. So say you pack one part for 10 seconds, the next part for 11 seconds, after that 12, and so on and so forth. Then you weigh all of those parts and you see at what point the part weight stops increasing. When the part weight stops increasing, you know that no more material is able to push through that gate and pack out your part further. So you can go ahead and stop packing. So we are essentially going to simulate that process to determine our gate freeze time.